synchronous binary counters. In this, all the flip-flops change simultaneously after the propagation delay associated with the single flip-flop. Count pulses are applied to the control input C of all the clocked flip-flops. That is, here you can see that all flip-flops can change simultaneously after the propagation delay associated with the single flip-flop. So what is the difference between the asynchronous and synchronous? Here you can see, here this is also a 4-bit binary up counter only, but this is synchronous type. How it is synchronous type? Because the count pulses, see here, C, the C of each flip-flop is connected simultaneously to all the flip-flops, right? In the asynchronous, what happened? This Q0 bar, Q1 bar, Q2 bar, Q3 bar was connected to the count pulses. Now what has happened? The count pulses are connected directly, right? And the count enable, how will come to know that it is 1 or 0 here? See here. The Q0 output is given as a one of the input to the AND gate, and the count enable is given as a one of the input to the AND gate. If Q0 is 1 and count enable is 1, then only the output of the AND gate will be 1 and then is given as an input to the T. What does it mean? If count enable is 1 and the output of the previous flip-flop is 1, that time the AND gate output will be 1 and then it is given as an input 1 input to the T. If one output of the first AND gate is 1 and it is connected to the T, then it will toggle, right? So next you can see here the Q1 is connected as a input, one of the input to the second AND gate. Next the count enable is given and next your Q0 output is also given. Q1 output, Q0 output and count enable, 3 inputs to this. If all the count enable, Q0, Q1 all are 1, then only the output of the AND gate is 1 and then it is given as an input to the T input of the third flip-flop, right? Now similarly next AND gate, here you can see Q0, Q1, Q2 and count enable. All these previous flip-flop output Q0, Q1, Q2, right? You can see here Q0, next Q1 and next Q2 and next the count enable. If all these 4 input lines are 1, then the output of the third AND gate, which is connected to the last flip-flop, T input of the last flip-flop is 1. Then the 1 is provided to this and this flip-flop, the last flip-flop will toggle during the positive edge triggered of the clock, right? Here you can see the AND gate preceding each input T detects if all the lower order bits are in one state. If yes, then the flip-flop will toggle on the positive clock edge. Drawback. What is the drawback? AND gate have many inputs. That is the drawback. But students, you need to learn the difference between the synchronous and asynchronous. In synchronous, what happens? The count pulses are applied directly, simultaneously to each flip-flop. Whereas in asynchronous, the output of the one flip-flop is connected as a count pulses input to the next flip-flop. Right? So what we have done here, this also counts in the binary up fashion only. We have to detect whether the previous output is 1. If it is 1 and the count enable is 1, then only T will be 1. Right? So what you understand by this flip-flop is it is a synchronous type. The count pulses are applied directly or simultaneously. What is the drawback of this? The AND gate having many inputs. So the solution for that, right? See, you can see here 4-bit synchronous binary counter variation. Okay, how do we do the counter variation? See here, again the first AND gate, Q0 is connected as an input to one of the AND gate and the count enable. If both are 1, then only it will be 1. So directly what we will do here is, instead of taking the output from the various each flip-flop output, we will take the output of the AND gate. Right? Instead of taking the output of the each flip-flop, we will take the output of the AND gate. So here I have taken the output of the AND gate and next previous flip-flop output, right? Similarly this one, the output of the second AND gate and the previous flip-flop output Q2. So previous output of AND gate is 1 and Q2 is 1, then only this AND gate will be 1. So this 1 will be provided to the T input of the last flip-flop during the positive edge, that is rising edge from logic 0 to logic 1 of the clock. That time this T input will toggle. If it is 1, if the T input is 1 and the clock is transiting from 0 to 1 edge, then only it will toggle. Okay. So the output of AND gate preceding the ith flip-flop consists of the inputs of the AND gate preceding the I-1 flip-flop and the output Qi minus 1. What is it trying to tell here is, see here student, the last gate you observe, okay, how many inputs are there for this? 4 inputs are there, right? So in order to stabilize the output of this AND gate, we should know the 4 line, whatever the data is present on the 4 lines. Whereas here what happens, see every AND gate is having 2 inputs. This is the variation counter, okay, of the synchronous 4-bit binary up counter. So what happens, each AND gate is containing 2 inputs only, the previous flip-flop output and the count enable. And here what happens, the output of the AND gate and the previous flip-flop output. Here also in the last flip-flop, the output of the second AND gate and the output of the previous flip-flop, right? So what happens here, the input to the AND gate is the previous flip-flop output and the previous output of the AND gate, previous AND gate output. This is for this gate, this is the previous AND gate. So the output of the previous AND gate is connected as the input to the next AND gate and Q2 is connected. Right? So all the flip-flops are positive edge triggered T flip-flop, positive edge triggered T flip-flop. They will toggle if the input is 1 and the clock pulse count enable is 1 and the clock is rising from 0 to 1, from logic 0 to logic 1. Okay. Next, mod m counter. Use a mod 2 raised to n counter as a mod m counter. You can load initial binary number prior to the counting operation. You can reset the counter by putting 0, 0, 0, 0. Counter structure is modified to allow for parallel loading. Right? JK flip-flops are used instead of T flip-flop. I have also explained you the JK flip-flop. Right? So two enable signals are there, load enable and count enable. Okay. So here provisions are made for load enable, allowing the parallel loading of the data inputs D0, D1, D2, D3, count enable which allows for counting. So here you can see the mod m counter, a symbol is there. You can see a symbol is there. What is this? Mod m counter. D0, D1, D2, D3 are the data. It's the load input is there. Count input is there. Count enable, load enable. The count pulses. Okay. C out is the carry out. Okay. This is the count pulses. C is count pulses. C out is carry out. Q0, Q1, Q2, Q3. Okay. So here, what happens here? Difference is JK flip-flops are used and two enable signals are used. Load enable and count enable. Load enable is having higher priority than the count enable. One to allow parallel loading of the data inputs D0, D1, D2, D3 and a second one for counting. If the load enable is 1, we will try to load the data D0, D1, D2, D3 into the JK flip-flops. If load enable is 1. If the count enable is 1 and load enable is 0, that time it will start counting. Okay. Operation synchronized with positive edge of the count pulses. The load function takes precedence over the count function due to the NOT gate connected to the load enable line. See here, we have a NOT gate connected. Okay. You can see a NOT gate connected. Load enable is having higher precedence. Higher precedence means higher priority. If load enable is 1, count enable is 1, then load enable will be given a higher priority than the count enable. Okay, so this is a modem counter, this is a symbol, and we are using JK flip-flop. We have this also counts 4-bit binary up counter 0000 up till 1111. So we have a load enable and a count enable signal. Count enable is 1, load enable is 1. That time what happens? Load enable is having higher priority. The data gets loaded into the JK flip-flop. Okay, this is all AND gates is internal construction, it is shown. Okay, and if we have here the Q3 output and the output of this AND gate is connected, if it is 1 then it is a carry out, and the count pulses are applied simultaneously. It's a synchronous modem counter. Okay, so here